The thousands and thousands of structures that sparkle at us on starry nights in the firmament make us aware of how small we are in the overall galactic context, which undiscovered worlds might still be slumbering in the gigantic expanses of the universe. Which entities, and possibly life forms, are waiting to be tracked down by our earthly eyes. With every discovery that experts make in the cosmos, we add another piece of the mosaic to the overall picture of the universe. It becomes particularly exciting in those cases where the researchers come across entities that are hiding in the remotest corners of the universe. Find out how scientists recently succeeded in identifying the most distant star of all time, and what other astronomical discoveries made the headlines in today's video. Excited about the groundbreaking discoveries and fascinating spectacles in the universe? Earendel. In the solar system, no other celestial body comes close to the impressive dimensions of our central host star. The Sun has a diameter of just under 900,000 miles. To put this in perspective, our blue home planet would fit inside our bright parent star over 1.3 million times. However, our massive Sun is nothing compared to the isolated star that experts were recently able to locate with the help of the Hubble Space Telescope. Researchers estimate the mass of the celestial body to be 50 to 100 times that of the Sun, making it shine millions of times brighter than our central star. It's well known that light from distant stars sometimes take billions of years to reach our Earth. This is also the case with this exciting new discovery. Before the emitted light reaches us, it travels the gigantic expanses of space for about 12.9 billion years. In other words, the star already existed when the universe was just 7% of its present age. After its discovery, the celestial body was christened Earendel. This term has its roots in Old English and means something like rising light or morning star. Why the discovery of Earendel, which was formed just 900 million years after the Big Bang, is a real sensation becomes clear when we consider the following. Normally, such distant and thus old stars can no longer be identified individually. They are typically much too faint that we could nevertheless add Earendel to the star maps. We owe to the so-called gravitational lensing effect. In the world of astronomers, this describes the deflection of light by large masses. Basically, the light from a distant source, such as a star or galaxy, is affected by an object that appears to be in front of it. In this case, the light deflected by such a gravitational lens is deflected toward the mass to a greater extent the closer it passes the cosmic lens. Although Albert Einstein predicted the gravitational lens effect as early as the 1930s, several decades would pass before the phenomenon was observed and officially confirmed. In the meantime, experts are taking advantage of this effect and some of its variations to identify a wide variety of remote objects. When particularly massive galaxy clusters act as galactic lenses, the bodies behind them sometimes appear as multiple images. For this reason, a quasar in the constellation Pegasus greets us 4 times from the firmament. With the help of the gravitational lensing effect, experts have succeeded in the past in detecting single, separated stars. Until now, however, the search for such distant objects was subject to a fixed limit. Anything further than 9 billion light-years from Earth could not be identified. Consequently, Earendel's distance of 12.9 billion light-years also sets a new record. In the course of their discovery, scientists received help from a galaxy cluster in the foreground. This amplified the starlight 1,000-fold, so that Hubble was able to capture Earendel on an image. The initial discovery of the celestial body should lay the foundation for further, more informative investigations. Through spectroscopic analyses of the James Webb Space Telescope, experts hope to reveal some fundamental characteristics of the distant star. These include, in particular, the question of whether Earendel was a single star or a binary system. This exciting research is like a cosmic journey into the past. Because of its presumed large mass, the object has probably long since exploded. Galactic milestone. The year was 1992, when a team led by Polish astronomer Alexander Wolszczyn identified the first 2 exoplanets in history. Now, 30 years later, scientists have reached the next milestone in this exciting field of research. They succeeded in cracking the 5,000 mark. In fact, experts were recently able to add 65 previously unknown extrasolar planets to the star charts. Remember, exoplanets are planets located outside the solar system and gravitationally bound to another host star. The fact that our distant cosmic neighbors are sometimes drastically different was proven by the first discovery in 1992, when experts discovered two planets orbiting not a sun-like host star, but a rapidly rotating pulsar. From then on, it was clear for the experts, if planets exist in the realms of such a neutron star, then they could occur practically everywhere. As is well known, the assumption proved to be true. In the past decades, scientists have tracked down thousands of further exoplanets. Although we now know of the existence of more than 5,000 such celestial bodies, it's estimated that billions more planets are waiting to be discovered, and that's just in our own Milky Way. No less exciting, every second potential host star could serve as a gravitational fixed point for an Earth-like planet. In other words, with every new exoplanet discovered, the chances that we will find extraterrestrial life increase. Enigmatic solar waves. However, in view of the countless planets and objects yet to be discovered in the future, we should not forget one thing. Even the celestial bodies we know about are still accompanied by some big questions. Among them is a mysterious phenomenon that astronomers have recently been able to detect on the Sun. This concerns a new form of high-frequency plasma waves, which cannot be assigned at present to a comprehensible context. As part of these processes, asymmetric vortices are formed near the solar equator, which then move in opposite rotational directions around our parent star. The researchers were particularly astonished by the fact that the plasma vortices move 3 times faster than all previously known solar waves. What underlies this unexpected phenomenon is still completely uncertain at this time. One thing is certain, however, due to the temperature differences in the interior of the Sun, the interactions of the plasma with the magnetic field, gravity, and self-rotation, wave-like instabilities in the plasma occur repeatedly on the Sun. In the case of these novel observations, however, previous explanations are reaching their limits. After analyzing data from a 24-year-old study, astronomers realized that this unknown type of plasma wave extends practically around the entire Sun. In doing so, it forms a coherent composite of vortices that rotate alternately clockwise and counterclockwise. Experts are still completely in the dark as to the background of this phenomenon. Pluto's unique ice volcanoes. The fact that so-called cryovolcanism exists in our solar system is not a new discovery. In fact, cryovolcanoes have already been detected on several icy moons of the planets Jupiter, Saturn, and Neptune. As the name of these formations suggests, cryovolcanoes do not spew boiling hot lava, but easily meltable substances such as methane, water, ammonia, or carbon dioxide. The corresponding substances are present in the interior of the celestial body in a frozen state. The heat present there causes the substances to melt and make their way to the surface. The ejected then solidify again and can pile up to form deposits many hundreds of feet high. The evaluation of data from the space probe New Horizons over Pluto suggests the conclusion that the former member of our planetary system harbors a form of the ice volcanism never observed before. First, however, a fundamental question had to be addressed. Do ice volcanoes exist on Pluto at all? To get to the bottom of this mystery, the experts looked at 2 promising candidates, massive mountains that culminate in gigantic crater plains. After analyzing the data and some images, it was clear Pluto's mountains do not have much in common with classic ice volcanoes. In fact, with diameters of up to 33 miles, the summit depressions are too large and too irregular to have collapsed subsequently. Furthermore, the scientists could not find any traces of ejected material. The fact that the entire surrounding area is adorned by elevations many hundreds of feet high and up to 12 miles wide, a circumstance that appears extremely unusual for conventional ice volcanoes, seems all the more strange. Since the terrain shows practically no impact points, the corresponding region must be relatively young. This hypothesis is also consistent with the fact that the mountains studied consist largely of frozen water ice, which has a thin mantle of organic deposits, frozen methane, and nitrogen ice. The different thickness of the layers shows that the different parts of the area were not formed together, but at different times. But what is the background of the Pluto Mountains? If one follows the explanations of researchers, then the area is the result of a unique cryovolcanism. At first, viscous but mobile water ice flowed to the surface, where it created huge elevations. Later, the individual hills merged to form the coherent hilly landscape that Pluto presents to us today. If this exciting thesis is confirmed, it would also mean that the dwarf planet is significantly warmer in its interior than the experts had previously assumed. In fact, the internal heat would be the basic prerequisite for water ice to become mobile enough to slowly emerge from the subsurface.